Hello, ladies and gentlemen, and welcome back. Welcome back. We're on question number 3 of the 2003 Euclid Math Competition. It's got 2 parts, light bulb and a big written question. The function, here we're doing part A now. The function f of x has the property that f of 2x plus 3 is the same as 2f of x plus 3. I believe, if memory serves, this is what's called a linear function, and I would expect this, if we actually worked out what f is, to be a line. So this is true for all x. If f of 0 is 6, what is the value of f of 9? Okay. So f of 9. Well, so with these questions that involve a function that is not defined and really hard to actually work out what it is, they tend to scare people away, but all we've got to work with is just that one property of f. That's the only thing we need to concern ourselves with. We don't need to be finding roots of f or anything silly like that. All we need to do is say, okay, f of 9, the only way I know to talk about f is to use this property here. So if I want f of 9, I need to write 9 as 2x plus 3. And then that'll be able to express it as 2 times f of x, and that'll be a smaller x than f of 9 plus 3. And then that f of x, maybe that's 0, or maybe that's a smaller value, and I need to work that way down, that all the way down to keep using this f of whatever, and keep working that all the way down until I get an expression involving any of the f's that I know. In this case, only f of 0 equals 6 will do. Okay? So let's see what we're talking about. So we know f of 0 is 6, and f of 2x plus 3, the constants and the multiplication and the sum, they pop out. So f of 9, if I want to talk about that, that's ultimately what I want to get. Well, that's going to be, how do I write 9 in this form? Because that's the only way I know to expand f, and this is the only trick I know. Well, I can write it as 2 times 3 plus 3. 6 plus 3 is 9. Okay? And now, thanks to this property, the 2 pops out, and it's f of 3 plus 3. So if I knew what f of 3 was, I would know what f of 9 is. I don't know what f of 3 is. I only know what f of 0 is. So we'll do another step. f of 3 is, well, I need to write that as 2 times something plus 3, and I need that to be 3. Well, 2 times 0 plus 3. And that makes sense having that 0 there, because now we're going to get 2 of f of 0 plus 3. f of 0, I know what that is. So this is 2 times 6 plus 3, which is 12 plus 3, which is 15. So now I can sub that back in. f of 9 is 2 times f of 3 plus 3, but that's 2 times 15 plus 3, which is 30 plus 3, which is 33. Nice, simple answer. So we'd write 33 in our little blank spot that they provide in the answer booklet. And that was 3A. That was quite quick, actually. Now let's go back 3B. This one also appears to have some functions. Suppose the functions f of x and g of x satisfy the system of equations. Okay, f of x plus 3g of x is equal to x squared plus x plus 6. And 2f of x plus 4g of x is equal to 2x squared plus 4. And this is true for all x. Okay. Determine the values of x for which f of x is equal to g of x. Okay. So, we want to solve f of x equals g of x. We want to know what x's do that. But our knowledge of f of x and g of x are tied up in this system of equations. So we can only relate f and g this way. All right. So what can we do? Well, we could try and work these two equations around to give us f of x minus g of x equals 0 or something like that. But what I'm going to do is I'm going to say, all right, suppose I'm looking at a value for x for which f of x is equal to g of x. Then I can exchange all my g of x's with f of x's. So this becomes f of x plus 3f of x, that's just 4f of x, is equal to x squared plus x plus 6. Okay? So we can keep doing that. Alright, and let's see where that takes us. That's just our first impulse. If that breaks down, that's okay. It's a written question, so let's just say, suppose, I don't know, x equals a. We're looking at f of a is equal to g of a. And at such a value for a, we got, I think it was a squared minus a plus 6. I think that's what it was. Let's just double check. Yep. Oh, no, plus. A squared plus a plus 6. This over here is f of a plus 3f of a, which is equal to 4f of a. And what's the other one? 2f of a plus 4g of a is, I think it was 2a squared, and then I have no idea what the rest of that was. 2a squared plus 4. Okay. But this over here is 6f of a, just like we said before. So we've got one equation here, which is 4f of a is a squared plus a plus 6. And our second equation here, 6f of a is equal to 2a squared plus 4. This is just based on looking at values of a where f of a is g of a. We want to find these values. Okay. So, I've got a system of equations here. And whatever I do to one side, I got to do to the other side. What I want to do is I want to eliminate these f of a's. Frankly, they're getting in the way. I don't know what f is. I don't know what g is, so I can't properly do anything with them. I can't find roots or anything like that. So what I'm going to do is I'm going to multiply the top equation by 6. Actually, no, by 3. The bottom equation by 2. Then I'll have 12f of a on both left-hand sides. Then I can subtract the first equation from the second equation. I'll get a 0 on one side and some other quadratic on this side, on the right-hand side. And I can solve a quadratic. So a will be the roots of that quadratic. So this tells me, first of all, there should be at most 2 values of a that do this, that have f of a is equal to g of a. But we've got a healthy and, I would say, nice way to do this. So 3 times 1 and 2 times 2. We'll get 12f of a, and then we'll get 3a squared plus 3a plus 18. And then down here, 12f of a, that was the whole point, was getting both the same things on the left-hand side. 4a squared plus 8. And now we subtract. We get 0 over here. 3a squared minus 4a squared, that's minus a squared. 3a minus, there's no other a's here, so that's just 3a. And 18 minus 8 is going to be 10. So a is a root of a squared minus 3a minus 10 equals 0. I just changed the signs for all of them so I get a leading one for my quadratic. Well, we can try and factor this out, or we can quadratic, whatever you want to do. 2 numbers that multiply to negative 10, I'm thinking things like 1 and negative 10, or 2 and negative 5. And 2 and negative 5, well, they happen to add up to negative 3. So we'll get 2, and we'll get negative 5 here. And that tells me a is equal to 2, or a is equal to 5. Those are the only ones that make this true. And really, that's all we need to do. We've got our answer here. If we want to, we can give a final answer here. Say, so the only x values to make f of x equal to g of x are x equals 5 and negative 2. I think that's what I just had, right? Yeah, 5 and negative 2. So that's our final answer. We gave a nice little sort of therefore statement summing up what we've done. Okay? And this is not at all too unexpected, really. If we look at our system of equations, we've got quadratics on both sides. So we might expect f and g to relate using some quadratics. So there's no way a cubic is going to enter into here, most likely. Yeah, because we don't have any differences. So I don't think a cubic would ever enter in here. So quadratic and having the roots to this equation here being a quadratic, that should all make sense for the most part. There's probably another way to manipulate this system of equations to get f of x minus g of x equals 0 or something like that, and be able to properly write that. But I'm happy with the way I did it. So that's 3b, and that wraps up all of question number 3. So if you did this last question with the system of equations a different way than just plugging in f of x equals g of x, I'd love it if you just gave me a little sketch of your idea, because I'd love to know another way to do it. But other than that, we look forward to question number 4. Thank you for watching, and I'll see you guys for question number 4 next time.